and welcome to the debut episode of our brand new podcast, Talking COP. I'm Victoria, your host for today, and throughout the duration of this year's COP29 conference in Baku, Azerbaijan, we'll delve deeper into the current issues, challenges, opportunities, and solutions surrounding climate change with our team of sustainability and environmental academic experts, as well as some of our industry connections who are doing some amazing work to reduce our environmental footprint. Today, I'm joined by Grant Henshaw, Research Fellow in Building Physics at Energy House Labs, and Jamie Bursnell, Head of Technical and Innovations at home construction company Bellway. And we will be discussing the role that housing and house building can play in reducing our carbon emissions. Welcome to the show, Grant and Jamie.
Thank you for having us.
Yeah, good afternoon, Victoria.
So I think our main question for both of you today is, how big a role does household emissions play in our overall carbon use as a nation?
Yeah, about 27% of our total energy use goes to domestic housing, which is quite a surprising figure if you're not in the industry. So a lot of people think, quite rightly so, transport will take the dominant side of that, and it does, but they don't expect housing to be such a big component in the UK. And that kind of leads into the fact that about 80% of the UK homes that will exist in 2050 are already built. We've got probably the oldest housing stock in Europe. So we use all this energy to heat our homes and cool our homes and so on. But the very leaky buildings, the houses that we already have, so a lot of that just gets dissipated to the atmosphere, into the outside environment.
So I think you're making a great point there with leaky homes, but you know the main bit is probably fossil fuels and the extra kilowatt hours of fossil fuel that is actually being burnt by those existing housing stock. And obviously each kilowatt hour of gas burn then has its environmental impact. So there's the commerciality, sorry to use the word commerciality, but there's the cost impact of a UK resident heating a leaky home. Which is one thing, particularly in the period we've had with relatively expensive utility costs, so the cost of gas moving up, the cost of electricity moving up. So it has that commercial impact. But obviously, then if you're multiplying kilowatt hours through the carbon intensity of gas or electricity, that's where the carbon footprint of the UK comes from. From a house builder point of view, we kind of have regulation that says that our heating hot water has to sort of fall within X efficiency and have X emissions. But the other bit that we're starting to sort of wrestle with as an industry is the unregulated, so the appliances that we purchase and hand over to our customer. So by appliances, so that's the cooking and the other appliances that the customer will have in the house. So I think what Grant's referring to, if 27% is coming from space heating from the household, a big percentage of that is going to be coming from the more out-of-date fossil fuel heating sources that may be comparatively less costly to run than some of the modern alternatives, but come along with a carbon cost. So there's a commercial pounds per kilowatt hour, but to each of that there is the carbon cost. So I think if everybody starts thinking in terms of cost of utility against the carbon cost of that, then that's probably a good way for us to start to realign ourselves to future goals.
Amazing. Thank you for making that make sense to me as well. So I think the next question, Grant, this is aimed more towards you. How far can retrofit go in reducing carbon emissions from our homes?
So we have a test facility called Energy House 1, and that's existed for about 13 years now. And its full focus is around retrofit. So within a climatic environmental chamber, we have pre-1920s end-terrace Victorian buildings. So it's very typical here in the northwest of England, but also if you imagine the kind of buildings you see on Coronation Street, it's pretty much one of them. So we're all familiar with these kinds of houses. So over the past 13 years, we looked at how to retrofit this dwelling in various different ways and see what the energy saving was. So we've done multiple iterations of these studies. If we do a full house retrofit, we look it looks like we can reduce the HTC, the heat transfer coefficient, by about 50%. Now, the HTC is how much power that building needs to heat, divided by internal external temperature difference. So if it's 15 degrees warmer inside than outside, and it's 100 HTC, it means it'll need 1,500 watts of heat to maintain a comfortable temperature in there. It's a bit technical, I know, but if we think about that 50% reduction in HTC, that's roughly 50% reduction in the energy bill for the occupant. So that sounds amazing, but that's very expensive to do. These big interventions in terms of retrofit are costly, and most homeowners, we just don't have the money to spend that much to fix our housing. So that's where we also need to look at low cost solutions, but then also hopefully government grants to subsidise these bigger interventions.
Grant, could you give us some examples of that, please?
Yeah, so during some projects we've tested, say, installing external wall insulation. So that's essentially wrapping the building in a big blanket. You can think of it that way. So that reduced the HTC by about 40-45%, which is a huge saving. And you have to bear in mind this is an end terrace, so you have a full other exposed wall. It probably wouldn't be quite that impactful if it was a mid terrace, say. Another part was changing from quite bad double glazed windows to more grade A type double glazed windows, and that reduced HTC by about 4%. So again, these aren't massive numbers, but again, if you shifted that to a mid-terrace property where your glazing makes up a much larger part of the external envelope of the building, so the parts that are facing the outward environment, then that would be more impactful. So it's kind of more knowing what interventions are relevant for that building as opposed to just a blanket rule for all houses.
I think there's other areas there. So, for instance, loft insulation. So some of the areas that we have as a new developer also apply. So we're looking at ways to reduce our heat losses. So how do we construct a wall, for instance? At what level of insulation do we put in a floor? Roof insulation is probably, I don't like to use the word low hanging fruit because I don't like too many buzzwords, but it absolutely is, particularly in the retrofit market. If you haven't had it already done, an extra 150 mil of loft insulation is going to pay for itself very quickly in its energy consumption. As is, we're still using gas boilers in the run up to the Future Home Standard. In fact, we're a hybrid dual energy at the moment. We're gas, but we're applying solar PV to the roof, so we're giving our customer a level of free energy. But we're also designing the boilers that we do run at a lower temperature flow. So rather than the gas boiler having to take the temperature in the radiators up to 80 degrees, in our gift we can design larger radiators, run them at a lower temperature flow, less heat in, less gas burn, more efficient. But then alongside, I think, Grant, you'd probably agree, there are things you can do to the fabric of either an existing home or a new home, but actually training the customer to live with either a lower temperature flow or even turn your thermostat down a couple of degrees. It's a little bit like driving your car at national speed limit of 70 mile an hour compared to driving it at 65 mile an hour. No, you're going to burn less fuel. So that would be the same with your home. If you've got your thermostat set at 24 degrees, if you reduce that to 21, I think you're going to have the same level of thermal comfort, but you're going to use a bit less energy as well. So as well as getting out there and spreading the message about topping up loft insulation, looking at wall insulation, I think there's a lot of time spent with the other kind of communication measures, which is, if you do upgrade your roof insulation, then what you need to do is adjust your heating controllers. Otherwise your home suddenly becomes warmer and you haven't realised the cost saving or the carbon saving. So there are those that information and that training.
Yeah, perfect. Thank you both so much. Jamie, this one's directed a bit more to you, but again, Grant, if you have anything to say afterwards, feel free to. How seriously are house builders taking CO2 reduction when planning buildings?
So, Victoria, I mean, there's I mentioned earlier, there's the regulated part, and then there is the, what's the right thing to do. So, I was speaking for Bellway, and a lot of our peers are similar. We have science-based carbon targets. So not only do we know what regulations are going to bring us, as an organisation, we've looked at how we operate, and we've made a commitment to identify what our carbon footprint is. And then B, once we understand where our carbon footprint is, we can then take measures to commit to reduce it, and then work to that carbon reduction. We have a new ESG, so environmental, social, and governance strategy, which is publicised within our annual report and accounts, whereby we have pillars of what we want to do within the business. So, but one of the key pillars is carbon reduction. So, we've done the footprinting, we've made the commitment, and we're on the journey to making that reduction because we're committed to do so. I think before an organisation such as ours can commit to reduce carbon, you've got to understand where your carbon is. And again, speaking the consultancy talk, we've been on this journey for the last 3.5, 4 years, and our first sort of area for learning was getting our heads around a new set of acronyms. So ESG, TCFD, well to tank. We've had to suddenly go on this quite a steep learning curve to understand where our footprint is, and it's significant. So if I quote a number that's in our annual report, our carbon footprint in scope 3, and I'll give you a quick breakdown of scope 3. Scope 3 is all our downstream, so the use of sold product. We build houses. Grant's just mentioned earlier that there's a lot of carbon in the use of a home. We build homes. There's a lot of carbon in the use of sold product. We can break that down into what's regulated, i.e. what's our choice in the way of heating and hot water, but we can also calculate the energy use and the carbon emissions from the ovens we supply and the hobs we supply and the washing machines and dishwashers. But we've had to go on that journey to understand, well, what is the carbon impact of a washing machine, and are we purchasing the correct one to give our customer the chance of reducing the carbon footprint? The other part of our carbon footprint is our upstream purchase goods and services. So I think the industry had always had quite a good grasp of the energy used by a boiler or a heat pump, the carbon emissions associated with that energy. We've probably been on that journey for a while, and we've known it for probably the decade. What is new to house builders is the emissions from our supply chain, the purchased goods and services. So, for instance, the average Bellway home has 9,500 bricks. So, what is the carbon footprint of that 9,500 bricks? Now, that's been the challenge for house building. So, I think, again, over the last 3 years, we've been on this steep learning curve to understand the impact of 9,500 bricks that weighs 18 tons. So it's the extraction, processing, packaging of a brick. It's then the transporting of 18 tons of bricks from the factory to the building site, and then the end of life scenario at the reference 60 year. By the way, Bellway do build houses which will last a lot longer than 60 years. However, for our life cycle analysis, we use a industry sort of number of 60 year. At the end of the building's functional life, we have to make an allowance for how those products and solutions are dealt with. So, deconstruct, cart away, reuse, recycle. So all of those things that mean that as a developer, yes, we need sort of 9,500 bricks. And yes, we've got to shift 18 tons of goods, but we're already thinking about how do we support our supply chain partner in them reducing their carbon, because we've got a good plan with the Future Home Standard. We've got a good plan of how we'll decarbonise and make a material impact on the use of the sold product. We've got to take that same understanding and work with our supply chain to remove as much carbon from 9,500 bricks as we can.
Amazing. Thank you so much, Jamie. So the final question, and this is to both of you, is what are 3 things people could do tomorrow to reduce emissions?
Yeah, so on what you touched on earlier, Jamie, there's the boiler flow temperature. So at Energy House One, we did a piece of research for the charity Nesta, which fed into their, what's it called now? The Boiler Flow Temperature Money Saving Boiler Challenge. So you will have seen this. It went into government guidelines last year. You will have seen it on billboards around Manchester and the rest of the UK that if you reduce your flow temperature of your gas combi boiler from typically it's around 80 within the UK, and if you turn that down to 60 degrees, say, you can get about a 9% saving on your energy consumption. So the reason that works is not only are you not heating the water up as high, so you're using less energy there, but also when it's a condensing gas boiler, it allows more condensate to be produced, and it just runs more efficiently, the boiler. So that's a very simple intervention that most people could go out and do. Jamie, have you got one?
There are measures such as reducing draft through doors. For instance, one of the areas we found useful in our house when the smart meter arrived with the electric usage dial, go room by room and unplug certain items that you think aren't working or you're no longer using day to day. And I think they're described as vampire appliances. So you will have on standby certain bits of kit, widgets. You'll know the worst ones because the plug will be slightly warm to the touch. Actually, if you go and unplug those, spend a bit of do an energy audit in your house. What's plugged in? Does it need to be plugged in? And then I think you'll get some interesting sort of knowledge on what you're not using that's plugged in that is still using a considerable amount of energy over a period.
Yeah.
Jamie and Grant, thank you so much for chatting to me today and for telling all our listeners all that useful information. And thank you for taking the time out of your day to be here.
No, thank you very much for having us.